to MRL. In this learning session, we'll be learning the Quadrilaterals chapter of Ganita Prakash 8th NCERT textbook. In this learning session, we'll be learning the different deductions being discussed in the chapter of Quadrilaterals. Now here the deduction number 1, the first deduction is the diagonals of a rectangle are equal. We are given a quadrilateral ABCD and the opposite sides of the quadrilateral are equal, that is AB is equal to DC and AD is equal to BC, and all the angles of the quadrilateral are equal to 90 degrees, that is angle A is equal to angle B is equal to angle C is equal to angle D, they are equal to 90 degrees. Now we have to prove the two diagonals, that is AC and BD, are equal in length. Now for that, let us consider triangle ABD. Let us take the triangle ABD and triangle BAC. I have shaded here triangle ABD and triangle BAC. In triangle ABD and triangle BAC, we know that AD is equal to BC because they are the opposite sides of a rectangle. Angle A is equal to angle B because all the angles are equal to 90 degrees. Therefore, angle A is equal to angle B is equal to 90 degrees, and AB is equal to BA is common. AB is equal to BA is common. That means by side congruency criteria, the two triangles, that is ABD and BAC, are congruent, and if the two triangles are congruent, then the corresponding sides are equal. Therefore, AC is equal to BD, and that is a very simple logical proof of the deduction. The diagonals of a rectangle are equal. Therefore, conclusion is the diagonals of a rectangle are equal in length. Now, deduction number 2, the diagonals of a rectangle bisect each other, or the diagonals of a rectangle intersect at their midpoints. Now, what is the meaning of this? Now, we have a rectangle ABCD. The AC and BD are the diagonals. Now we have to prove that these two diagonals, that is AC and BD, intersect each other such that they bisect each other, or O is the midpoint of AC and O is the midpoint of BD, or AC and BD intersect at the midpoint of the two diagonals AC and BD. Now we are given ABCD is a rectangle. Let us understand what is given to us first. ABCD is a rectangle. AD and BC are equal. AB and DC are equal. They are opposite sides of a rectangle. And also angle A, angle B, angle C, angle D are equal to 90 degrees. Now what we have to prove is that AC and BD bisect each other, or O is the midpoint of AC and midpoint of BD, or OA is equal to OC, OB is equal to OD. That is what we have to prove. Now to prove this, we'll go for the two triangles. Let us consider two triangles here, which I have already shaded here. In triangle AOD and COB, AD is equal to BC because they are opposite sides of a rectangle, therefore they are equal. AC is equal to that is AD is equal to BC. Now if you look at angle 1 and angle 2, they are vertically opposite angles, therefore they are equal. If you look at angle 3 and angle 4, they are interior alternate angles and therefore they are equal. Angle 3 is equal to angle 4 because AD is parallel to BC, AD is parallel to BC, AC is the transversal, angle 3 and angle 4 are interior alternate angles, therefore angle 3 is equal to angle 4. Now since angle 1 is equal to angle 2, angle 3 is equal to angle 4, but natural, the third angle of this triangle and the second triangle, that means angle 5 is equal to angle 6. So we have one side equal, that is AD and BC in both the triangles, and we have these two angles, angle 5 is equal to angle 6 and angle 3 is equal to angle 4. By angle side angle congruency criteria, the triangle AOD and triangle COB are congruent. So we have proved that these two triangles are congruent by angle side angle congruency, or even you can take it as double AS congruency also, but I prefer angle side angle congruency criteria. Now since the two triangles are congruent, the corresponding sides are equal, therefore OA is equal to OC and OB is equal to OD. If OA is equal to OC and OB is equal to OD, but natural, O is the midpoint of AC and O is the midpoint of BD, or the diagonals of a quadrilateral bisect each other. So that is what is the deduction, the logical proof of the given statement. Try to remember that. Now deduction 3. The statement is, in a quadrilateral, or the property is, in a quadrilateral, if diagonals are equal and bisect each other, then it is a rectangle. Now what is the meaning of that? We are given a quadrilateral ABCD. Now the diagonals AC and BD are equal and also they bisect each other. That means AC is equal to BD and O is the midpoint of AC and BD. Now we have to prove that ABCD is a rectangle. So let us see how to do that. Now what is given to us? ABCD is a quadrilateral that is given to us. Diagonal AC and BD are equal. AC and BD bisect each other, that means O is the midpoint of the two diagonals there. Now we have to prove that ABCD is a rectangle. Now let us take angle between the diagonals here. So if I take that is diagonal AC and BD, let the angle be equal to x. Now if I take this as angle as x, now you know that OD and OA, because now say the diagonals are bisecting each other, diagonals are equal also, therefore OA and OD are equal. And if OA and OD are equal, the angles opposite to the equal sides are equal, therefore angle OAD and angle ODA are equal to A and AC. That means I have taken this as A and A. Now if you take this triangle, A plus X becomes 2A plus X, and 2A plus X is equal to 180 degrees. Now 2A is equal to 180 minus X, A is equal to 180 minus X by 2, or A is equal to 180 by 2 minus X by 2, or A is equal to 90 minus X by 2. That means I have got the angle A as 90 minus X by 2. Now let us take the one more triangle, triangle AOB. Now if you observe, angle AOB plus X is 180 degrees, forms a linear pair. Therefore angle AOB is 180 minus X. AOB is 180 minus X. But in triangle AOB, angle AOB plus angle B plus angle B, because BB are equal angles, because the sides OA and OB are equal, therefore angle that we have the two angles equal here, angle B and angle B, because they are angles opposite to equal sides. Therefore in triangle AOB, angle AOB plus B is equal to 180 degrees, but we know that angle AOB is equal to 180 minus X. So substituting there, we get 180 minus X plus B is 2B is equal to 180. 180 cancels here, so X is equal to what? 2b. So we have got x is equal to 2b, or b is equal to x upon 2. So we have got the angle b as x upon 2. Now we already know angle A as 90 minus x by 2, angle B as x upon 2. When we add these two angles, angle A plus angle B, then we get 90 degrees. Therefore angle A is equal to 90 degrees. And so also similarly, if we find out other angles, we find angle B is 90, angle C is 90, and also angle D is 90, because here A plus B is 90, A plus B is 90, and A plus B is 90. So all angles are equal to 90 degrees. Therefore angle A plus angle B, angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degrees. Try to understand that. Now that we have shown the four angles of the quadrilateral, all the four angles of the quadrilateral are equal to 90 degrees. Now we have to show the opposite sides are equal for the quadrilateral ABCD to be a rectangle. For that, let us consider the two triangles AOD and COB. AOD and COB. In triangle AOD and triangle COB, we have angle x, that means angle x, these are vertically opposite angles, that is angle AOD and angle COB are vertically opposite angles, therefore both angles are equal. And since the diagonals bisect each other, we have OD is equal to OB and OA is equal to OC. Therefore these two triangles by side angle side congruency criteria, the two triangles AOD and COB are congruent. If the two triangles are congruent, the corresponding sides are equal, and therefore AD is equal to BC. So now we have proved that AD is equal to BC here. Now let us go to the another pair of triangles here. Let us take the triangle AOB and COD. In these two triangles, we have angle AOB equal to angle COD, vertically opposite angles, and OA is equal to OC and OB is equal to OD. Therefore by side angle side congruency criteria, triangle AOB and triangle COD are congruent. Because these two triangles are congruent, the corresponding sides will be equal, and therefore AB is equal to DC. So now here in this quadrilateral, we had proved all the angles to be equal to 90. Now we have proved that the side AD and BC are equal, and the side AB and DC are equal. That means opposite sides are equal. So therefore in a quadrilateral, if all the four angles are equal to 90 degrees and the opposite sides are equal but natural, the quadrilateral has to be a rectangle. That is exactly what I have mentioned here. I have written whatever I have just expressed to you. I have told you the same thing I have written, and therefore the conclusion is, in the quadrilateral ABCD, angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degrees, which we have proved, and we have just now proved that AD is equal to BC, the opposite sides are equal. AB is equal to DC, again opposite sides are equal. That means the pairs of opposite sides are equal in the quadrilateral. Therefore quadrilateral ABCD is a rectangle. Therefore, in a quadrilateral, the conclusion is, in a quadrilateral, if diagonals are equal and bisect each other, then it is 100% rectangle. So try to remember that. Now deduction number 4. The statement is, in a quadrilateral, or the property is, in a quadrilateral, if all the angles are equal to 90 degrees, then it is a rectangle. The meaning of the statement is that ABCD is a quadrilateral. Angle A, angle B, angle C and angle D are equal to 90 degrees. Now we have to show that the quadrilateral ABCD is a rectangle. Now let us understand how to logically prove it. Now we are given ABCD is a quadrilateral. Angle A, angle B, angle C and angle D are equal to 90 degrees. Now we have to show that or prove that ABCD is a rectangle. Now if you observe here, angle D is equal to 90 degrees. It means that angle 1 plus angle 3 is equal to 90 degrees. Let us call it a statement 1, equation 1. Now in the quadrilateral BCD, angle C is 90, angle C plus angle 2 plus angle 3 is 180, and therefore angle 2 plus angle 3 is equal to 90 degrees. We have got angle 2 plus angle 3 is equal to 90 degrees. Earlier in the first equation we had angle 1 plus angle 3 equal to 90. Here we have angle 2 plus angle 3 is equal to 90. It means that angle 1 plus angle 3 is equal to angle 2 plus angle 3. Angle 3 cancels. Now we have proved that angle 1 is equal to angle 2. So we have angle 1 is equal to angle 2. But angle A is equal to angle C, and that is 90 degrees. DB is equal to BD. Therefore, in triangle ABD, ABD and CDB, we have the side BD is equal DB is equal to BD. Angle C is equal to angle A, and angle 1 is equal to angle 2. That means by double A or side angle side or double AS congruency criteria, triangle ABD and CDB are congruent, and if the two triangles are congruent, then the corresponding angles are equal. Therefore, AD is equal to BC and AB is equal to DC. Therefore, we have a quadrilateral in which all the angles are equal to 90 degrees and the opposite sides are equal, but natural, the quadrilateral is a rectangle. So the conclusion is, a quadrilateral with all angles equal to 90 degrees is 100% rectangle. Okay, just try to understand and learn this particular example. Now coming to the next important deduction, that is deduction number 5. We here the we have to prove that diagonals of a square are equal, bisect each other and are perpendicular to each other. The meaning of this is, we are given a square ABCD. ABCD is a square given to us, and in a square, as we know, all the sides are equal. That is, AB is equal to BC is equal to CD is equal to DA, and all the angles are equal. That is, all our angles are equal to 90 degrees. Angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90. That is the property of a square. Now what we have to prove here is that AC, the diagonal AC and diagonal BD are equal. That is the first important thing we have to prove. And also we have to prove the diagonals bisect each other. That means O is the midpoint of both the diagonals AC and BD, or OA is equal to OC and OB is equal to OD. That is what you have to prove. And the third important thing what you have to prove here is that the diagonals are perpendicular to each other. That means AC is perpendicular to BD, or angle AOD is equal to 90 degrees. That means AC is perpendicular to BD. So let us understand how to prove these three important properties of a square. Now let us go to the first important property, that is, we have to prove that AC and BD are equal. And for that, let us consider two triangles ABD. I have taken triangle ABD and triangle BAC. ABD, this triangle ABD and BAC. In triangle ABD and BAC, we know that AD is equal to, please understand, AD is equal to BC, opposite sides of a square, and AB and BA are common. Angle A and angle B are equal to 90 degrees. Therefore, by side angle side congruency, side angle side congruency criteria, the triangle ABD and BAC are congruent. If the two triangles are congruent but natural, the corresponding sides are equal, and therefore AC is equal to BD. Rather, the diagonals of a square are of equal length. Now coming to the second property which we have to prove, we have to prove here that the diagonals bisect each other. We have to prove that the diagonals of a square bisect each other, or O is the midpoint of both the diagonals. Now I have redrawn the square here to understand easily. So we have the square ABCD here. Now let us consider the two triangles here, the triangle AOD and COB. In triangle AOD and COB, angle 1 is equal to angle 2 vertically opposite angles. AD is equal equal to BC, opposite sides of a square, and angle 3 and angle 4 are equal because they are alternate interior angles, because we know that AD is parallel to BC and BD is the transversal, therefore angle 3 and angle 4 are equal. So that means the third angle automatically it will be equal. Therefore the two angles of the triangle AOD and two angles of the triangle COB and one side AD and BC being equal, where that means we have proved that these two triangles are congruent. The triangle AOD is congruent to triangle COB. If the two triangles are congruent but natural, the corresponding sides are equal. Therefore OA is equal to OC and OB is equal to OD. If OA is equal to OC and OB is equal to OD, O is the midpoint of both the diagonals AC and BD. Rather, the diagonals bisect each other. Therefore, we have proved that the diagonals of a square bisect each other, O is the midpoint of both the diagonals. That is the second important proof. Now the third important point what we have to discuss, what we have to prove is the diagonals are perpendicular to each other. That means we have to prove that AC is perpendicular to BD. Rather, I have to prove that AOD, angle AOD is 90 degrees. And for that, let us consider two triangles. Let us take the triangle COD, this triangle COD, and also the triangle COB. I'll take this triangle COD and triangle COB. In these two triangles, DC and BC are equal because they are sides of a square, and also OD is equal to OB. Just now we have proved O is the midpoint of a diagonal, therefore OD and OB are equal, and OC is common to both the triangles. Therefore, by triple S congruency criteria, triangle COD and COB are congruent. If the two triangles are congruent but natural, the angle COB and COD are equal. So we have angle COB and COD are equal. But we know that angle COD plus angle COB is equal to 180 degrees because this angle plus this angle forms a straight line or straight angle DOB. Therefore, the sum of angle COB and COD is equal to 180 degrees. But we know that COD and COB are equal. Therefore, I can replace one of the angles in that. So I can replace COB by COD. Therefore, angle COD plus angle COD is equal to 180 degrees, or 2 times angle COD is equal to 180. Angle COD is equal to 180 by 2, or angle COD is 90 degrees. Now therefore, if angle COD is 90 degrees but natural, the diagonal BD is perpendicular to AC. That means AC is perpendicular to BD, and that is what is the proof of this particular deduction of square. So we have just proved that in a square the diagonals are equal, the diagonals bisect each other, and the diagonals are perpendicular to each other. They are the properties of a square, and try to understand and remember that. Now the deduction number 6. We have to prove here that the opposite angles of a parallelogram are equal. Now we are given a parallelogram ABCD here. We are given a parallelogram ABCD. Now we have to prove that angle A is equal to angle C and angle B is equal to angle D. That means opposite angles of a parallelogram are equal. Now to do that, we already know that in a parallelogram the opposite sides are parallel, that is AD is parallel to BC and AB is parallel to DC. If AB is parallel to DC, that means angle A and angle D, when we add, it is 180 degrees. We already know that because the co-interior angles are supplementary when we have AB parallel to DC and AD being the transversal. Co-interior angles are supplementary, and therefore angle A plus angle D is 180, and so also angle C plus angle D is also 180 degrees for the same reason. Now we have angles A plus angle D is 180, angle C plus angle D is 180. Therefore angle A plus angle D is equal to angle C plus angle D, and angle D and angle D cancel. Therefore we have proved that angle A is equal to angle C. Similarly, we can take angle B plus angle C. Similarly, we can take angle B plus angle C as 180 degrees because again co-interior angles are equal. Angle D plus angle C is also equal to 180. Now RHS is we have 180 degrees as the RHS here, so we can equate angle B plus angle C is equal to angle D plus angle C, and angle C cancels here. Therefore angle B is equal to angle D. Therefore the opposite angles are equal in a parallelogram. So we have proved that angle A is equal to angle C and angle B is equal to angle D. Therefore the opposite angles of a parallelogram are 100% equal. Try to remember that. Now coming to deduction number 7, now what we have to prove here is the opposite sides of a parallelogram are equal. We have to prove that the opposite side ABCD is a parallelogram. We have to prove that AB and DC are equal, and also AD and BC are equal. So let us see how to do that. Now what is given to us? ABCD is a parallelogram, and so AB is parallel to DC and AD is parallel to BC. Now we have to prove that the opposite sides are equal. That means I have to show that AB is equal to DC and AD is equal to BC. Now for this, let us do a construction, join BD. So join BD, we have got two triangles here now. In triangle ABD and CDB, ABD and CDB, we have angle 1 is equal to angle 2 because they are the opposite angles of a parallelogram. Opposite angles are equal. Angle 3 is equal to angle 4 because alternate interior angles, because AD is parallel to BC and BD is the transversal, and therefore angle 3 is equal to angle 4, and BD is common to both the triangles, and therefore by angle side angle congruency criteria, the triangles ABD and CDB are congruent. If the two triangles are congruent, then the corresponding sides are equal. Therefore AB is equal to DC and AD is equal to BC, and that is what is the logical proof of the statement given to us. That is the property given to us, that the opposite sides of a parallelogram are equal. A very simple logical proof of this is given to you. Now coming to the next deduction, deduction number 8, that is the diagonals of a parallelogram bisect each other. We are given a parallelogram ABCD here. Now AC and BD are diagonals. We have to prove that AC and BD, the diagonals, bisect each other. That means we have to prove that O is the midpoint of AC and BD, or we have to show that OA is equal to OC and OB is equal to OD. So let us see how to do that. Now we are given ABCD is a parallelogram, AC and BD are diagonals, and we have to prove that diagonals bisect each other. And for that, let us consider the two triangles AOD and COB. So these two triangles are which I have shaded. I have taken the triangle AOD and COB. In these two triangles, we know that AD is equal to BC, opposite sides of parallelogram. Angle 1 is equal to angle 2, alternate interior angles. Angle 3 is equal to angle 4, alternate interior angles. Therefore, by angle side angle congruency, these two triangles are congruent. If two triangles are congruent, corresponding sides are equal, and therefore OA is equal to OC and OB is equal to OD, or O is the midpoint of AC and BD, or the two diagonals bisect each other. And a very simple proof, and try to remember that. So that is what is the meaning, that O is the midpoint of both the diagonals, or diagonals bisect each other. Now coming to the deduction number 9, the opposite angles of a rhombus are equal. Please try to understand the property here. The opposite angles of a rhombus are equal. Now what is given to us? We are given ABCD is a rhombus, and you know that in a rhombus all the four sides are equal. Now we have to prove here that the opposite angles are equal. That means I have to prove that angle A is equal to angle C, and angle D and angle B are equal. Now for that I will join BD. When I join BD, I get two triangles here. I have got two triangles here, triangle ABD and triangle CDB. Now let us see, in these two triangles AD is equal to BC because the sides are equal, and angle 1 and angle 4 are equal because we know that AB is parallel to DC and BD is the transversal. Angle 1 and angle 4 form the alternate interior angles, and therefore they are equal. And so also angle 3 and angle 2 are equal. That means alternate interior angles. So 1 is equal to 4, angle 3 is equal to angle 2. And therefore in these two triangles, DB being common, DB is common here, and DB and BD are common, and angle 1 and 4 are equal, angle 2 and 3 are equal. Therefore by angle side angle congruency criteria, the two triangles ABD and CDB are congruent. If the two triangles are congruent, the corresponding angles will be equal. Therefore angle A is equal to angle C. Angle A is equal to angle C. So try to remember that. Now the two sides are equal here. Therefore angle 1 is equal to angle 2. And the two sides are equal here, therefore angle 3 is equal to angle 4. Rather, all the four sides are equal, therefore angle 1 is equal to angle 3, angle 2 is equal to angle 4. Therefore when I add angle 1 plus angle 3 and angle 2 plus angle 4, both the angles will be equal, or angle B is equal to angle D. So try to remember that. So that is how we can prove that in a rhombus all the the opposite angles are equal. In a rhombus the opposite angles are equal. So try to understand that. So try to understand how I have shown that angle 1 is is equal to angle 2 is equal to angle 3 is equal to angle 4, because 1 is equal to 4, 2 is equal to 3, but 1 is equal to 2 and 3 is equal to 4. Therefore 1, 2, 3, 4, all the angles are equal. The sum of 1 plus 3 and 2 plus 4 must be equal. Therefore angle D is equal to angle B, and that is exactly the method of proving this. Try to remember that. Now coming to the next deduction, that is deduction number 10. The diagonals of a rhombus are perpendicular to each other and bisect each other. We have to prove that the diagonals of a rhombus are perpendicular to each other and also bisect each other. We are given a rhombus ABCD, and all the four sides are equal, and we have to prove that the diagonal AC and diagonal BD are bisect each other, and also they are perpendicular to each other. That means I have to show that O is the midpoint of both the diagonals, that is rather OA is equal to OC and OB is equal to OD, and also I have to show that one of the, that is angle AOD or angle DOA or angle DOC is 90 degrees. Let us see how to do it. Now let us consider two triangles AOD and BOC. I have taken these two triangles AOD and BOC. In these two triangles AD and BC are equal because because sides of a rhombus are equal, and angle 3 is equal to angle 4, alternate interior angles, because we know that AB is parallel to DC and BD is the transversal. Therefore angle 3 and angle 4 are equal, and so also angle 1 and angle 2 are equal for the same reason, and therefore by angle side angle congruency criteria, the triangle AOD and COB are congruent. If the two triangles are congruent, then but natural, the corresponding sides are equal. If the corresponding sides are equal, that means OA is equal to OC and OB is equal to OD. That means the diagonals bisect each other, or O is the midpoint of the two diagonals, or the two diagonals cut each other at their midpoints. That is what is the conclusion. Therefore the diagonals of a rhombus bisect each other. That is what you have to remember. Now the second part is we have to prove that the two diagonals are perpendicular to each other. So let us see how to do that. So let us go further. Now I have taken two triangles here, AOD and COD. I have taken two triangles AOD and COD. In these two triangles, if you observe very carefully, in AOD and COD, OA is equal to OC, just now we have proved, and OD is common to both the triangles, and AD and CD are equal, that is the sides of the rhombus are equal. Therefore by SSS congruency criteria, these two triangles are congruent. If the two triangles are congruent, the corresponding angles are equal. Therefore angle 5 and angle 6 are equal, but angle 5 plus angle 6 is equal to 180. Therefore 2 times angle 5 is equal to 180, or angle 5 is equal to 180 divided by 2, or angle 5 is equal to 90 degrees, or angle DOA is 90 degrees. Rather BD is perpendicular to AC, and that is exactly what I have written here. That means that whatever I just told you I have written here. So please go through this and try to understand. Therefore it's very clear now that the diagonals of a rhombus are perpendicular to each other, the diagonals of a rhombus bisect each other, and that is what is expected of us to prove. So this is how we can prove the various properties of quadrilaterals, which are mentioned as deductions. The 10 of the deductions of the quadrilateral chapter are discussed, and they are very simple deductions, logical deductions based on the known theorems or known properties, which we already know them, we have used them, applied them to prove these deductions. So always remember, the proof of theorems or deductions should be given step by step with all the steps, because 5 steps are involved in this, and for every step we write, we have to give the reason. Without giving the reason, we cannot go to the next step. So for every step you have to give the reason in proving any kind of theorem or deductions. So these are logical deductions, and applicable, these properties are applicable to any quadrilateral where these properties are used and proved. Okay, remember that. So learn them, practice them, and note down them as a future reference for your study. Okay, thanks.